So today we're going to be discussing proportions, percentages, rates, ratios, unit conversions, and statistics. Later in the afternoon, Marley will cover the rest of statistics. With percentages, it's a part over a whole times 100. And if we take away 20%, 100% minus 20% is 80%. We want to translate percentages as a word problem. What is X? Is equals, of is multiplied by, percent means divided by 100. And these are the three ways we can set it up and solve it through. And all of them would get you the same solution for this question right at the bottom. All right, so some things to note. A ratio is a comparison of two quantities. The ratio of A to B can be expressed these two ways. A proportion is an equality of ratios. So it's kind of like, 36 over 60 equals X over 100 to find the percent of that. And it would help you find an unknown quantity. And a rate is, the formal definition is a quotient of a ratio where the quantities have different units, but it could be something like distance over time, or later today we're going to see kilograms over meter cubed, where we might have one variable and have to find the other. But a rate is usually two different measures of things and how they relate to each other. Okay. So in this question, an artist advertises an enlarged model of a scorpion fly. And so just to make sure we're getting it correct, it's an enlarged model. And the scale of the model to the original is 36:1. The model has an enlarged width of 170. And so it wants to know, assuming these measurements are accurate, how wide is the original scorpion fly? So if it helps, you can do model to original, which gives us 36/1, which also equals 1170 millimeters over X. And so we get 36X equals, and I think this is 35 or 32.5. 32.5. So it's really important to read the full question, because I think sometimes we're used to it being where we're looking for the larger number. But in this situation, we're looking for the smaller original. And also usually like models in our head, we think are smaller. So it's just important to see that it's a blown up model of the original. Make sure I'm not missing any questions in the chat. Okay. Keep moving on. A watt hour is a unit of electrical energy equivalent to power consumption of 1 watt for 1 hour. Watt times hour for the watt hour. This is important. If it was like, watt over hour, it would be a different solution, as we'll see. So how much energy in watt hours is to keep 6-watt light bulbs for 4,800 hours? We would just do 6 times 4,800, which gives us answer choice D. It would be really common and normal to assume, 6 goes into 4,800 really easily. If it's a watt hour, and what I don't like about this question is that it says, 1 times 1 equals 1, but 1 divided by 1 is also 1. So you can't really tell which way it goes. So you really have to work off the English, which is the watt hour, which would be watt times hour, and not watt divided by hour. So it's answer choice D. But if this, let me see, is there a question? Oh no. How did you know it's multiplying? That's a great question. We know it's multiplying because it says watt dash hour. In another question, you'll see that it would say like watt per hour if it was division. So like watt per hour would be watt over hour. But if it's watt hour, I would very quickly write, if you see a dash, a multiplies. Um, that's the only thing I can say really. Okay, good. Um, but I will say the first time I did this, I did it wrong and I thought it was watt per hour because that's what I thought. And it makes, I really don't like this question because 1 times 1 is 1 and 1 divided by 1 is 1, but the SAT likes to do this. Um, One thing I've been harping on a lot this week is that since the test is digital, it's really important to just use your paper or chicken scratch to write down little notes to yourself so that in the minute and a half, 90 seconds, 60 seconds, 2 minutes, you don't miss something that was important. So just having like little like oh times and on the side is really helpful. Um, okay, so this question says, which of the following cities has the largest population density in 2010? And what it's asking is, what is the A column here divided by B column, and which one is the largest? And so before this, I don't like this many integers, this many numbers. And so what I would recommend for a question like this is that um, I'm going to go ahead and switch screen to my screen here on my laptop. So I actually just I would just sit down on the test. I mean, you're already sitting down, but I would take the 30 seconds to type each one out and just see. And this is answer choice A, B, C, D. Um, and that just gives you the answer the fastest. You could round and test it out too, or you could eyeball it and probably get close, but I would actually just punch out each one. Um, and the largest one is answer choice A. So the answer is, where is this one? Sorry. It would be Boston, which was the largest. Does anyone have questions on this? All right. Um, let's go right back to, okay. So I just pre-wrote the answers here, or the choices for us, but it is answer choice A. Now we're going to move on to center, spread, and shape of distributions. And so I just added the definition of what standard deviation is, but the SAT does not use this. It's just in case you're interested in statistics, it would be a little bit different. And in case you're taking a statistics class, they're just really trying to see, I'll explain. So the most important thing to note is the center, which is mean, median, mode. I think we know that. Mean is average, median is the middle, and mode is the most. The spread is the variation of the data. So from the largest value to the lowest value, and it's usually the difference between those values. And standard deviation is on the SAT, it's spread from the mean, the typical spread from the mean, and it's the average distance between the mean and the value in the data set. And so they're not going to ask you to find the standard deviation, but they're going to ask you what data set has the largest or the smallest standard deviation. And so we will go over that in the example problem, but just in case anyone wanted to know what standard deviation is, then that's the definition. Okay, so mean is average, median is middle, mode is most, and range is largest minus smallest. Okay, in this example, we have 4 numbers in X, and we're told that the mean of the 5 numbers is above 30. Oh, the mean of the 5 numbers is 30. Oh, sorry, above means these numbers there. What is the value of X? So we get 20 plus 20 plus 40 plus 60 plus X, all divided by 5 to get the mean. And we're told it's 30. And so if we solve it out, 20 plus 20 is 40, 40 plus 40 is 80, 80 plus 60 is 140. 140 plus X equals 30 times 5, which is 150. We subtract 140 from each side and we get X is 10. Anyone have questions? What I would, yeah, so we'll do this one for now like that. Okay, now we have this data set where Marco scored in the last 6 ball games and how many points he scored. And Marco forgot what he scored in the second game, but his coach told him that he averaged 10 points per game. So the equation is just like the last one. It's 11 plus X plus 13 plus 7 plus 9 plus 12, all divided by 6 equals 10. And so if we add all those numbers up, we get 52 plus X equals 6 times 10, which is 60. And so we get X is 8. And if you're really comfortable with mental math, another way to do it that I like to do is that if I'm told the average is 10 and I know there's 6 games, I just start with 60 has to be the sum of everything here. And you really don't need to push yourself to do this, but 13 plus 7 is 20. And 11 plus 9 is also 20. So it would be 12 plus X equals 60 minus 20, which is 20. So X also equals 8. That's only if you're extremely comfortable. And I think this method would be really easy to make silly mistakes. I wouldn't recommend it, but if this is simple and easy for you, then that's a trick I just wanted to show you all. Okay, but I would just say stick to this and you're not going to get it wrong. Okay. This one's a little bit funkier, but the dot plot depicts the annual snowfall in centimeters in Syracuse, New York during the 1990s. Maybe that was supposed to be a comma. Rounded to the nearest 10 centimeters. Which of the following statements offers the best explanation of the mean and median of this distribution? Okay, what is the mean? What is the median? And before we look at these dots, if I look on the right, I can see an answer choice A, median snowfall is less than the mean, okay, because it says the annual snowfall greater than 130 centimeters, and there's years where it's less. Then it says the median snowfall is greater than the mean because 130. So 130 centimeters is important. And then I see C says they're the same, and D says there's not enough information. And so not enough information is sometimes an answer choice, but we want to try first. So I can see 130 is important. What I would do is actually find the mean. And so this is 70, this is 90. These two are 100. These two are 130. This is 160, these two. This is 170, and this is 190. If you punch it into your calculator and add it up, we get 1,300. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data sets, which means that 130 is the mean. Okay. Now I want to find the median. Okay. And so the way to find the median is really simple. I cross off on each side. 1, 1 is gone. 2 on each side. The 2 highest and the 2 lowest are gone. Now the third and fourth highest and lowest are both gone. And we're stuck with this in the middle. And you actually cross out both and you would average what's in between. And it would be the same number because they're both 130. And so the median is 130. So they're the same. And so the answer choice is the median snowfall is approximately equal to the mean snowfall because the data distribution is symmetrical. And we didn't even need to check if it's symmetrical, but if we wanted to, I mean, if the mean and median equal each other, it is symmetrical, but the way they canceled out was very elegant. This is 1, 2, 3, 4, 5, 6 spots away from the center. And this one is also 6 spots away. These are 4 away, 3 away, 4 away, 3 away. That's what it means by symmetrical. See if anyone has questions. Cool. Let's go to the next one. This one I also thought was really funky, but it says the graph gives us the average temperature in degrees Fahrenheit, city A and B, over the same 7 days. MA is the median and SA is the standard deviation, and MB, SB is for city B. And so what we're going to do is sorry, I like to color code this. Let's do MS for standard deviation. Just make that a little higher. Okay, that's fine. And so, make sure there's no questions, sorry. Okay, if you just joined the class, can you type in your first and last name for attendance? Okay, so the way to do this question, which I think is gross and I think is actually really hard to do on the digital SAT, unless you do a lot of chicken scratch, is write the highest and lowest points. So on city A, the highest point is 58-ish, and the lowest point is 38-ish. And I would put the median, or the median or mean, about the same on this line at about 45-ish. And then for city B, I would say the lowest is 48-ish, and the highest is 53-ish, and the median, which for standard deviation would be mean, but I'd put it at 50-ish. Okay, and so the median for city A, I made, oh my God. For A is the 45. And for B, it's 50 for the median. And for standard deviation, this is a little bit harder, but it would be the distance between like the mean or median, mean and median I would use interchangeably, but the big thing to notice is that city A is a lot more dramatic, with the differences between the top and the bottom, so the standard deviation is bigger. So I would put it at, this difference between here is 7-ish and this is 13-ish, so let's just call it 10-ish. And the standard deviation between 50 and 48 and 50 and 53 is 2 or 3-ish. So let's call it 2-ish. Even if we made it 3, it should be the same. And what this tells us is that the median for city A is less than city B, but the standard deviation for city A is greater than city B, and that would be answer choice C. Does anyone have questions? The other thing you can do is you can cover up, you could just, I have to illustrate it, but you could go ahead, cover up one side, figure out if it's a lot of numbers and letters, is median A greater or less than B? And it's less than, so you can cross out A and B, and then you can uncover this side and see a standard deviation A greater or less than B, if it's hard to look at. All right. Are there any questions before we move to our practice problems? All right. Anyone that just joined, can you type in your first and last name in the chat? I think there's 2 of you. So we need that for attendance. Or I can type it. Thank you. Yeah. All right. Let's take 2 or 3 minutes to do this question. And when you have the answer, if you can put it in the chat. We have 1 submission. All right. Okay, so a regular price of a shirt at a store is $11.70. And the sale price of the shirt is 80% less, which also means that it's 20% of the regular price. And then the sale price is 30% greater than the store's cost for the shirt. So it wants to know, what did the store pay for the shirt? So we have 2 steps here. The first is we have to find the sale price, which is 20% of $11.70, which if we use our calculator, do 0.20 times 11.70, and I get $2.34. Now the second step is a little bit tricky. And what I would do is write an equation that looks like the sale price equals 30% is 30% greater than the store's cost. So what the sale price is 30%, I don't know how to write this better, but 30%, I'm gonna write the equation. It's 30% greater, which means it's 1.30 times C, the store's cost. And so then we would do 2.34 equals 1.30 C. Maybe another, I'm trying to write this in a way that's easy to understand. It could be so it's like 1, when it's like in math class, it's like 1 plus 0.3. It's like for 30% greater. That would probably be a good way to show it. Okay. And then we have 2.34 is the sale price, and it's 1.3 C. So C equals 2.34 divided by 1.3. And so C equals 180. And so the answer is $1.80. Does anybody have questions on this problem? This is something I would expect more towards the end of the test, which sucks because there's a lot of parts to it. And, if you don't catch this 80%, 20%, you can be way off and spend a lot of time. So take little notes and make sure the equations you're writing look just like the word problems. All right, let's try this question. When you have the answer, type it in the chat for me. Maybe one more submission in the chat, and then I'll go ahead and solve it. Nice. Okay, we have 3 now. So a candle is made of 17 ounces of wax. When the candle is burning, the amount of wax in the candle decreases by 1 ounce per every 4 hours. So I write 1 ounce, 4 hours. Everything I'm writing is what I would write if I were taking the exam on my piece of paper. Okay. And if 6 ounces remains in this candle, for how many hours has the candle been burning? So we start with 17 ounces and we end with 6 ounces. So the difference is 11 ounces, and 1 ounce takes 4 hours. So then 11 ounces would also be times 4, which is 44 hours. D. Does anybody have questions on this? Let's give this one a go. And this one I'll give you 3 minutes to work through. All right. So a sample of oak has a density of 807 kilograms per cubic meter. How do we write that? 807 kilograms per meter cubed. That's how we write it. The sample is in the shape of a cube. I forgot how to draw a cube. There we go. That's a cube. Where each edge has a length of 0.90 meters. Okay. To the nearest whole number, what is the mass in kilograms of the sample? That's really important because the volume of a cube, once we solve for it, will be meter cubed. And so we're going to use the variables properly for that. So 0.9 cubed, which is the volume of a cube, is, I believe, 0.72. But let me just check that. It's 0.729. We're always going to check our work. Okay, and so we're going to do 807 kilograms per meter cubed times 0.729. I'll write that better. Okay. Meter cubed equals, the meter cubes cancel out. And so we're going to do 0.729 times 807, and we get 588.303. But since it says nearest whole number, it's answer choice A. Density, you do not need to know this for the test, is mass times volume. Okay, and mass would be meter cubed. Yeah, and volume is kilograms. Is it? No, mass is it's the other way. Anyway, it's density equals mass times volume. And the, yeah, let me just do this. So density equals, no, is it mass divided by volume? Yes, sorry. It's mass divided by volume. And so we get kilograms over meter cubed, and kilograms is mass, and meter cubed is volume. I'm sorry about that. You do not need to know that for the test, but it's just trying to, the SAT wants you to know that when you see kilograms per cubic meter, you know how to write it. And that if you see the sample, the shape in the cube, you're trying to find the volume to get meter cubed, not just meter, right? 0.90 is just 1 meter. And then to find kilograms, you need the meter cubes to cancel out. All right, let's go to the next question. Let's try this one. Okay, so we have data set A consists of the heights of 75 buildings and a mean of 32 meters. So I'm going to write A is 75 buildings and mean equals 32. Then we have data set B, which consists of 50 buildings and the mean is 62. Now we have data set C, which has the heights of all the 125 buildings, so 75 plus 50, from data set A and B. And so it's asking what is the mean in meters of data sets C. So mean, okay. It might make sense in your head to just add 32 plus 62 divide by 2, but that's not correct because it's not weighted correctly. We would do 75 times 32 plus 50 buildings times the mean of 62. So we take the mean times the buildings in each data set to get our big number before we had gotten the means for both A and B. And then we divide the whole thing by 125. And that gives us X, which is our mean. Okay. And when we do the math, 75 times 32, 2400 plus 50 times 62, 3100. Add them up. I get 5500. Sorry, my handwriting is horrible. When we do that, we get X equals 44, which some of you got. Okay, so since I didn't record the beginning of class, and this is our last question, why are you multiplying? Okay, sorry, there are questions. So the first question is, do we do 32 plus 62 divided by 2? We don't, because we would only do that if it was 50 buildings and 50 buildings. If the data sets had equal entries, then we could take the means and just add them to each other and divide by 2. But because it's weighted differently, we have to take the weights into consideration. So Eliana also asked, why are we multiplying the means? That's also why, because if you have 75 buildings and the mean is 32, you have to go almost backwards to get the full, right? So mean is the total data entries all summed up divided by the total number of entries. But we only know if we do 32 and 62, we have no way of weighting them for the differences. And so what we do is we multiply them to each other, add it up, divide by the number of entries, which is 125, and then we get the mean. For example, let's say, trying to give like a real life example that might be really helpful. But let's say you're taking the comparison of the heights of buildings in Manhattan and Brooklyn. Brooklyn on average is much lower than the buildings heights in Manhattan. But Brooklyn is a larger area, and so they may have more data entries. And so we can just say A is Brooklyn, 75 buildings, and the average height is 32, much less. But Manhattan has fewer buildings that are much higher. And so if we were trying to find the average between the two, we couldn't just take the average of, each one and then add it and then divide by 2. We would have to take into consideration each and every building in Manhattan and Brooklyn. You would only use 32 plus 62 divided by 2 if it was like this. Um, if it was like 50 buildings and the mean was 32, for like, let's call it D, okay? And let's say E was also 50 buildings and 62 was the mean, then um because you would, if you have 50 in each pool, um then you could do 32 plus 62 divided by 2 gives you the proper mean. But because you have more data points in set A, you don't do it that way. I don't know, does that help? Okay, yeah. And I think the Brooklyn Manhattan works really well because visually you would never just take the average of each one. You would take each building into account. And another way to show that, sorry, I just want to make sure we get this because this is important, is in, trying to find a good example that had that. So hmm, yeah, like in this example, um, let's say instead of it being the way that question was asking was, it's basically saying that it knows the mean of this, let's call this 8, and it knows the mean of this, and it's asking you to find the whole mean. You wouldn't take, you know, 11 and 9, the average is what, 19 divided by 2, 9.5, right? This is 9.5 for the mean, but 13 plus 7 is 20, 20 plus 9 is 29, 29 plus 12 is, I think, 41. Yeah, so this is 41. And so this mean is, I mean, it kind of works here, but is 10.25. So the average of 9.5 and 10.25 is not 10. It's only 10 if you multiply 9.5 times 2, which gives you 19. And then you do 10.25 times 4, which gives you 41. Then 41 plus 19 gives you 60. And then when you divide by 6 total games, then you get the average of 10. I think that should help explain why. Just different numbers of data sets. But if it were 3, 3, you would get it. If it were this and this mean, so 11 plus, this is 8. 11 plus 8 is 19. 19 plus 13 is 22. 19 plus 13 is 32, right? 24 plus 8 is 32. Yeah, and then 7 plus 9 is 16. 16 plus 12 is 28. Then you could take, divide by 3, divide by 3. 32 divided by 3 is 10.66 equals the mean. And 28 divided by 3 is 9.33. So then if you add 9.33 plus 10.66, you get 20, and 20 divided by 2 is 10. So then you could do it that way if it's even. It's like even if the numbers are different in the over here, as long as there's 3 equal entry points, then you could do it that way. But if there's unequal entry points, you can't do it that way. You have to break it out. Okay, so I think Lily might join soon if she hasn't already. But what I'll do in the meantime, just because I forgot to record in the beginning, so just for the sake of the YouTube video, is I want to redo this question. And so you're welcome to take a bathroom break while we wait for Lily, but just so that anyone who missed it can do this properly. So a student answered 86 problems correctly, which was 81.9 of the total number of problems on the test. how many problems did the student answer incorrectly? So we're trying to find first the total number of questions. We don't know. 86 over x equals 81.9 over 100. 86 times 100. If we isolate x, that's what it gives us. And the answer, if you use your calculator, is 105. And so what we would do then is do 105 minus 86, and we would get 19. Answer choice B. And yeah, if the quantities are the same, you do not need to do multiplication. That's correct. Okay, and so that's for this question. If you're, the first time I did this, I actually did this wrong and I didn't see incorrect. And so another way of doing it, actually, that's the only way to do it. I'm sorry, we went over this. Hey, Lily, are you here?
Yes, I'm here.
Let me,
Hi. Hello, everyone.